Question 5. A student suspended a spring from a laboratory stand and then hung a weight from the spring. Figure 1 shows the spring before and after the weight is added. Okay, so we have the retort stand with a spring without a load, and the same, the retort stand and the spring, but it has a weight this time around, and we have a ruler on the right. Question A. Measure the extension of the spring shown in figure 1. Now, in order to do this, we have to pick a particular point and compare it to the ruler. So in my case, I am going to choose the bottom of the spring. So from there, we have to draw a horizontal straight line to the ruler, and I have to do the same from the bottom of the spring which has the weight. Now, to find the extension, we have to find the difference between these two readings. So the first reading is at 10 centimeters, the second reading is at 11.3. So to find the extension, all we have to do is 11.3 minus 10, which will give us 1.3 centimeters. That's pretty straightforward. Let's go to question B. The relationship between the extension and the force on the spring can be explained using Hooke's law. Describe Hooke's law. All we have to do here is state Hooke's law, which I had said earlier in the year we have to learn by heart. Hooke's law states that the extension is directly proportional to the load as long as the elastic limit is not exceeded. It is very important to mention all of the things mentioned here. So you have to say that the extension is directly proportional to the load, and this only applies if the elastic limit is not exceeded. Okay, it is very important to not forget the second part. We're moving on to page 6 for question C. The student continued the investigation by increasing the range of weights added to the spring. All of the data is shown plotted as a graph in figure 2. And here we have the graph. We have the weight going from 0 to 10 on the x-axis in newtons. We have the extension in centimeters going from 0 to 35 on the y-axis. And we have the points scattered throughout. Note that here we have a good example of a best chosen line. It's not a best straight line because at the end, as we know with graphs about Hooke's law, they tend to curve towards the extension. Okay, let's see what the question is going to be for part C. At the end of the investigation, all of the weights were removed from the spring. What can you conclude from figure 2 about the shape of the spring? Now here it is important to look again at the graph. And since the graph starts as a straight line but then curves upwards, then we know that the elastic limit has been exceeded. Now we've also learned that if the elastic limit has been exceeded, then the spring will be deformed, meaning it will not return to its original position, but although it will get shorter, it will not reach the original length. So from this we can conclude that the spring will shorten but will be longer than it was originally. Going on to part 2, give a reason for your conclusion. As we've already said, the reason it will shorten but it will be longer than it was originally is because it has exceeded the elastic limit and this will cause it to be deformed permanently. Since the spring exceeded its elastic limit, it has been permanently deformed. And that concludes question 5.